Hello, hello. Big crowd. You're so quiet. Right. Hope you're all having a great time. Good, good. So I'm Richard Cook. I'm a developer on the Hyper team at Tableau. So I was very excited when VJ demoed Hyper at the keynote yesterday. That was very exciting. And I'm also very excited today to introduce the session, the Zen Masters. And right now, I'm going to introduce Adam McCann and Chris DiMartini, who are going to, right? Yeah. Hey, you got some fans out there, all right? And this is a Jedi Charts session, and they're going to blow your mind with a demonstration of all their advanced charting techniques in Tableau. So I'm just going to say a few words about the guys. So Adam McCann comes from Deloitte Consulting, and he leads teams of data scientists who build predictive models and do business intelligence stuff. He also teaches information visualization at the Maryland Institute of Art. It's Maryland. I'm English. I don't know how to pronounce that. And he loves to blog about sports, movies, and politics. Meanwhile, there we go. Meanwhile, Chris comes to us from Visa, and he's, all right, we have Visa fans in the audience. Okay, that's great. So Chris is a director in data visualization, and he loves sort of injecting dynamic aspects into Tableau vizzes, some of which he will touch upon today. And he also blogs. He does some stuff with Datablick. All right. Wow. you got fans. And what else can I say about Chris? He loves pushing Tableau to the limits, sort of proving what you can and cannot do with the product. And hopefully we can keep on doing more and more. And what else can I say? Well, they met at TC last year, and they sort of got to know each other through Twitter and the Tableau community. And on that note, I would like to call Adam up to the stage. Thank you.
So good afternoon, everyone. Chris and I are here today to talk about Jedi Charts, how to create custom chart types in Tableau. One of the things I hear from a lot of my clients is, I don't want to use Tableau because I have chart type X that I need to create, and this type of chart is not available out of the box in Tableau. And this could be any of the charts we're presenting here today, or some of the other charts that Chris and I have posted on our respective blogs. But what we're going to walk you through today is how to create 4 different custom chart types in Tableau. I'm going to do 2, and then Chris is going to come back on and follow with his 2. So the first, we've already done introductions. I'm going to start with a gauge chart and a sunburst. I'm going to caveat when and when not to use a gauge chart, so don't worry about that. And then Chris is going to come on and talk about jump plot, which is awesome, and then he's going to close with a hive plot. Oh, and then Q&A will be at the end there. And then Bill Murray's creepily following my mouse along. And so Chris and I's hypothesis is that any chart type is possible in Tableau, as long as you, A, properly plot your points, and then B, connect those points together. And so what we're here today is walking through how to create these chart types, but our theory is that you can really create any chart type in Tableau. Unfortunately, sometimes it requires math, which some people don't love to do. But I think what we're going to try to do today is demystify some of the complexities of some of these visualizations. The details of the visualizations we're going to create, our Tableau public file will be posted to our respective websites. So don't worry about following the details of our calculations or how we did everything. You'll be able to download the workbook and reverse engineer what we did. The idea today is to go over at a high level what we're doing, how we're doing it, when to use these chart types, when not to use these chart types, in some case more importantly. But we're going to start with a gauge. A gauge is a controversial chart type in the data visualization community. Stephen Few, a luminary in the field of data visualization, does not love gauges. But there are benefits to a gauge. A gauge is very easy to understand. It is a single metric on a 180 degree, in this case, or 360 degree axis, representing one point relative to a range of points. And why you should use this? You should use it to show a point relative to a single point or a range of points. When you should use this, generally you don't, but if you do want to piss off Stephen Few, this is the chart type for you. Stephen Few does not like gauge charts. He has many blog posts on his website, Perceptual Edge, and many things in his books, which are all excellent, and Stephen Few is excellent, but he does not like a gauge chart. But my clients, our clients, they sometimes want to create gauges, and that's because gauges are everywhere. When we hear the term dashboard, most of the nerds in this room think of Tableau dashboards, but for the 99% of the people in the world, when you hear dashboard, you think car dashboard. And what is a car dashboard filled with? Gauges. They are easy to understand, they're very relatable, they're ubiquitous. I mean, there are gauges everywhere. And while it has a poor data to ink ratio, something that Stephen Few talks about a great deal, they are easy to explain. An alternative to a gauge chart that Stephen Few proposes, and I think is an excellent chart type, is, conveniently enough, Stephen Few's own chart type, which is called the bullet chart. A bullet chart does everything that a gauge chart does, but it has a better data to ink ratio. It's a more efficient visualization. It communicates the same information without wasting a good deal of real estate. For more information about these chart types and Stephen Few's very passionate opinion on them, I would definitely check out his website, Perceptual Edge, and all 4 of his books. But the problem with the bullet chart is I have to explain what it is, what the bar represents, what the vertical reference line represents, and what the colors represent. On a gauge chart, people know what I'm showing them. Doesn't need to be explained generally. Red is bad, green is good, low is bad, and high is good, or whatever you're visualizing. So with that caveat that it's not a perfect visualization, but it is everywhere, and clients ask, or users ask us to create them, I'm going to walk you through how to create a gauge. So there's really 3 steps. First, you need to create your X and Y coordinates. As I mentioned before, really any chart type is possible to create in Tableau as long as you plot those coordinates on an X and Y axis. And then secondly, connect those points together somehow. So the first step is create your points, second step is plot your points, and the third step is to pretty it up, do some formatting, add some background images, format, color, things like that. So to set up our data, we're going to rely on a parametric equation. So a parametric equation is a fancy way of saying putting points on a circle. And so for that, we have both an X and Y coordinate. These are the formulas. Again, I'm not going to walk through how to do it. You can download, I'm not going to walk through each of the formulas, but you can download the workbooks and reverse engineer it. The key part is A1 in that formula, both in X1 and Y1, which are our key X and Y coordinates. A1 in this case is an angle, which is represented by our 180-degree spectrum from left of the gauge to the right of the gauge, multiplied times some normalized value. So I'm going to walk through how to create that normalized value. So this is using Superstore sales. We all have access to this data set. This is sales by product subcategory. I just picked product subcategory. You can do it with any dimension, any measure, but again, this is sales by subcategory. The first thing I need to do to create a gauge is normalize my value. So I use a value of sales divided by window max of sales to convert everything from 1 equals max sales to 0, which is $0 in sales. And so I see phones has the highest value. It's 100%. Chairs is the next highest value. It's rounded to 100%. It's probably more like 99.8. All the way down to the bottom, close to 0%. What I then do is plug that angle, my normalized value, into my angle. So multiply my normalized value times 180 degrees, and then insert it into my parametric equation. So 1 plus square root of 2 times cosine of my angle, 180 degrees times pi divided by 180. That produces my x, and then the same formula below produces my y. And then all I need to do is plot those points. So over here I have my measures that I've created. X value, Y value. I drop product subcategory into my view, and then I compute using product subcategory. And so now I have a point on a semicircle that represents every product subcategory. All the way to the left here is my lowest value, because it's normalized to 0, fasteners, to my highest value, phones and chairs. But the problem is that I don't want all those points on my circumference. I want to recognize a single point and where it falls on that circumference, and then all other points should disappear. So the final part of my equation of the calculated field is to use a parameter, where I select what dimension I want to see or what product subcategory I want to see, and then use a calculated field to say that if I have selected my parameter, return the x coordinate. So return my point on my circumference. If I have not selected that product subcategory from my parameter, put the origin point at 1, 1. So now I have 2 points on my scale. The selected value, somewhere on a 180-degree spectrum, and a point at 1, 1. The reason we need that 1, 1 point is so that we can connect the lines together. So right now, the original chart was in a circle chart. I have now since converted this to a line chart, and now the two lines are connected to one another. So now you can start to see our gauge taking shape. As we alter our product subcategory, our line swivels around the circumference. The next thing I do is add a background image. To do that in Tableau, you go to Map, Background Images, select your data set. I'm not going to do that here, but you select your data set, and then you format your image. I created this image in PowerPoint. You can do it in any program, Paint, Photoshop. Insert the background image, and so now you have reference points. You have chart tile data represented by red, or I'm colorblind, so whatever color that is, yellow, and blue. And then the last thing I do, make it pretty. So I've removed my axes, removed some of the extraneous borders. I've actually attached a value to my endpoint here, so that when I change my product subcategory, the end color of my stick changes. And I had done that by duplicating one of my variables, and so now I have a line connecting the two lines on our points, and then a separate circle that is a separate circle that is over top of the line. So again, gauges aren't the greatest chart to create. It is possible to create them in Tableau. You don't need to restructure your data. All you really need to do is create your x and y coordinates and connect those coordinates together, add some background images to produce the gauge look, and then tie it to a parameter. So a sunburst chart. So the second chart I'm going to go over today is a sunburst chart. A sunburst chart is good for showing hierarchical part-to-whole relationships. And it is one of the few chart types that does this very well. And so the visualization I'm showing here is a company that has departments, IT, finance, and then has offices that align to those departments, and then finally has employees that work in those offices. So there's 3 levels to my hierarchical structure. So this is a good visualization for showing part-to-whole relationships within a hierarchy. When you should use this, when you have a complex hierarchy, why you should use this, when you should use them, sorry. Tree maps is one way in which people tend to show hierarchical structures and part-to-whole relationships. And tree maps are available out of the box in Tableau. The problem with tree maps is that when your hierarchical structure gets beyond 2 or 3 parent-child relationships, you can no longer discern the parent-child, because what Tableau does automatically is uses physics to lay out, or uses math to lay out and plot the rectangle so it optimizes the space, and you don't have any control over the parent-child relationships. How much does Stephen Few hate this chart? He's commented a few times on sunburst. He doesn't really like them, but essentially the problem is that sunbursts are a bunch of pie charts stacked up one on top of one another, and if you haven't read Stephen Few's books, he's not a huge fan of pie charts. So this is one alternative to using a sunburst chart, a tree map. This is, again, showing the data set I'm dealing with. Department is the color, and it's the largest rectangle. Within those rectangles, you have bigger rectangle or smaller rectangles, which represent the office they're in. So I have finance. The office they're in is San Francisco. And then finally, the smallest rectangle is the employee itself. All of it is sized by how much money they make. So you can see Bob in New York and Jan in New York both make the most amount of money. But it looks like most of your money is going to your finance group and your IT group. The problem with this structure is that it's hard to drill into the parent and then the child and then the grandchild. And when the hierarchical structure is complex, it's hard to drill into it. Another alternative to a sunburst chart and to a tree map is icicle chart. So an icicle chart is a chart that Manuel Lima talks about in his book called The Book of Trees, which is a great book on hierarchical data visualizations. It's all about tree charts. An icicle chart is not a chart type available out of the box. I do post a how-to on my website, duelingdata.com, so if you do want to check that out, it's up there right now. But an icicle chart does have the benefit of being able to see there are multiple levels of your hierarchy. At the highest level, you see the finance department, then you see the offices that align to finance, and then finally you see the employees in your finance department. Stephen Few would like it more because you're comparing distance in some cases and also area. It's easier to interpret than a 360 degree on a sunburst. But obviously, it's still a very high data to high ink ratio chart. So communicating a lot of information because it's very complex data. So how to create a sunburst. One of the issues with sunburst is that you have to restructure the data. And I'll walk you through how I do that. Once you have the data structured together, structured properly, you create every single pie chart. You size those pies by the level that you're visualizing, and then you use a formula to stack those pies together. So a normal data structure looks like this. You have a row for, in this case, every employee. So I have Plaxico, Amani, Tiki, Elite. I'm a Giants fan, for those of you who've picked it up. This is not a real company. So usually your data set has the lowest level of granularity. In this case, it's employee. So you can see that Plaxico formerly worked for this company. In the New York office and the finance department, he made $40,000. This is how you typically want to structure your data set in Tableau. But for a sunburst, what you need to do is change your level of detail so that every wedge in your pie chart gets a row. So if the data set on the left, my original data set had 23 employees, I want the data set on my right to have 23 employees, then every single office, and then every single department. So my first row of data is my department. My next row of data are the offices that align to that department. And then the final rows of data are all the employees that align to that office. And the only last thing you need to do is make sure that every child adds up to their parent. So on row 3, the salaries combined add up to 220. 120 plus 100 adds up to its parent department office of finance at 220. So you need to make sure that the children within your lowest level of granularity add up to the parent level of granularity. And you can do this through SQL. You can write SQL statements. We do it at Deloitte using R statements. So we pull the data out, we run an R script, we pass it through into Tableau. But you can do it doing SQL, Python, R. There's a variety of things you can use to transpose your data in this format. So what you're left with when you bring your data in and you render it as a pie chart is a big, ugly pie chart with a wedge for now every employee, every office, and every department. And all I've done is dropped department into my color so that I'm highlighting the wedges by department. The trick is you need to space those points out so that the smallest pie is on the top and the largest pie is behind it. So I use my level ID, which is what level I'm in. If I go back to my data set, it's this value right here. So I use my level ID to size my pies. So the innermost pie is the smallest, then the second level is medium size, and the final pie is large size. And the last thing I do is create an X coordinate. The X coordinate is just a silly formula of my level ID divided by some random large number. I chose 1,000, but you could choose any value. And the reason I do that is so that I can stack those pies on top of one another. So when I adjust my axes, so that it's fixed at 2 points, my pies automatically stack on top of one another. And so now what I'm left with is a series of 3 distinct pie charts overlapping one another, where the data has a parent, a child, and a grandchild. All those wedges, because of our R or SQL statement, add up to the corresponding parent, and then they're sized properly so that each layer is visible. And then the last thing I do is I add in a white center in the middle, so that when I hover over my wedge, you can see what the value of the wedge is in the center point, and all this is a big white circle that I place over top of it using a dual axis. So that is Sunburst. So to go through jump plots and high plots, I'm going to bring Chris on stage, and then we'll follow with Q&A.
How's everybody doing? Good, I like the energy. All right, so I'm going to continue our session here today, and I'm going to take us through jump plots and hive plots. How many people here have seen a jump plot before? Can I see a show of hands? Awesome, that's way more than I thought I would get. Jump plot is a concept that my friend Tom Van Buskirk and I came up with about a year ago now, and it originates in a business use case that he had dealing with a situation where he had a sequence of events, and across that sequence of events, he may or may not hit every event along the way. And so there were multiple passes through the sequence of events, and he had a situation where he was trying to find out what was causing the delays, and how could he go about graphing this in such a way and see the detail he needed to see and identify the anomalies that may be in that. So we came up with jump plot, and just to help you, for those of you who haven't seen it, learn how to read the jump plot, what you're looking at from left to right is the sequence of events. This data that you're looking at here is related to marathon finishers. So the leftmost orange circle is the first finisher of the marathon. The second circle is the second finisher of the marathon, so on and so forth. And we have time in seconds elapsed between those finishers on the y-axis. And so we're looking at how much time elapsed between each of the finishers of this marathon. And the idea here was I was trying to see if there's any situation where we have, maybe an elite set of 10 runners or something like that and a big gap after those 10 runners finish the marathon. So that's how you would go about reading one of these. And now we can talk a little bit more about it. So why, when, and what does Stephen Few think? So why you should use it, I talked about that a little bit already, but ultimately it has to do with trying to identify outliers and repeated event sequences. And also, when you should use it is situation, pretty much for any event sequence you could use it, but ultimately it is structured in a way that it will benefit you if you don't hit every event along the way. Stephen Few, I don't know that he's ever seen one, honestly. He doesn't have any publicly available commentary on his blog about it, so we just left that as we don't know for now. Tom and I built a site after we came up with a concept just to try and help explain it and help people understand how to read it. You can reference that as jumpplot.com. If you go there, there's a lot of information on there in terms of the various things, the variations that we have with respect to it, the different implementations that have been done, Tableau and D3 being a couple of those, and other alternatives that you might want to consider when thinking about using a jump plot. And lastly, for a very detailed walkthrough on the Datablick blog, we have a very detailed session there where you can go through every single calculation that's being used to make jump plots happen in Tableau. So let's get into building it. So what you're looking at here is actually data from the ESPN Home Run Hit Tracker. I love this data set. It's one of my favorites. And this is Buster Posey's home runs from the 2015 season. He plays for the correct Giants team. And within the data that you see here, what I've done is I've taken the original 19 records for his 19 home runs he hit in 2015, and I've actually duplicated that data. So I took the 19 rows, copy and pasted it down. I'm doing this in Excel here just for example purposes, but ultimately you would be doing this in things like SQL and R, like Adam mentioned in his examples as well. As we copy that down, then we're going to have to build a couple of identifiers so that Tableau knows what it needs to do when we bring the data in. And so the various things that I've identified here are, for example, the series. This is all related to Buster Posey, so that's highlighted on there for you. In addition to that, we have the path ID. You may have heard people talk about the path ID before, but that's ultimately the identifier for every line or curve that we're going to draw in Tableau. And in addition to that, we have path order, which helps us keep things structured and sorted in the correct way. And that is done where you're going to go from event 1 to event 2, from event 2 to event 3, and that path order allows us to keep those things in the correct order. Now that we've taken a look at how we need to structure our data, we're going to utilize a technique referred to as data densification in order to build the curves that we're going to draw in Tableau. I learned a lot about data densification from Noah, who's sitting right here. And what we're going to talk about today is what happens to your data when you densify it. So I like to go back to this example I have here. And what we ultimately have is two bar charts. The top bar chart has just your standard number of records measure that you get whenever you connect to any data set. And the bottom bar chart has a window table calculation against that same number of records. What I'm going to do now, and the other thing is the domain, or the dimension, I mean, that is being plotted here is the binned value, and that bin goes from 0 to 100 by 1. And so as I go ahead and densify this, you're going to see this result. Now what happened on the top here is we have our raw field, we have our raw data field. And what you see is in the first record there, which is the value 0. We have a record in our underlying data, therefore it's populated with some value. And the same thing holds true for the value of 100. In our underlying data, we only have the value 0 and 100. On the bottom chart, you can see that we've taken that and we've used window table calculations in Tableau to copy that value across the entire densified value. So we have an actual value here in our underlying data. We don't have any values across any of the orange, and then again, we have one at the end. This is really important for us to do things like build histograms, and it's one of the tricks that we use to do things like build curves in Tableau. So the type of curve I'm going to draw is the Bezier curve, and those curves are used to connect the events in the event sequence for the jump plot. And one of the things I love about the Bezier curve is how much you can manipulate it and make it do whatever you want. Since we're building this directly in Tableau, we can go ahead and move these control points around, and you can see those curves react and change as I'm doing that. The curve itself is shown here in 2 degrees. So you have the quadratic degree of the curve on the left and the cubic degree of the curve on the right. The difference between those in the simplest form is you have 1 control point for the quadratic curve, and you have 2 control points for the cubic curve. The way the curve works is that you have a starting point, a control point, which is going to be somewhere around here for this curve, and an end point. And so with the cubic curve, you're going to have 2 of those control points, which allow me to make it look a little bit different as I'm manipulating those parameters on stage here. In addition to that, I just want to call out the Wikipedia page. It has a ton of great information, along with a really good animation right here. And that, to me, made it very clear how the math is working in order to draw that curve for us. So let's talk about how you would go about using these things to build a jump plot. So the first thing you're going to do with jump plot is you're going to plot your checkpoints from left to right. So you have, as I mentioned in my example before, the first finisher of the marathon and the second finisher of the marathon. And then you need to draw the curves between those events. And the way that we're going to go about doing that is by setting our control point. And we're going to set our control point based on 2 things. The control point is going to be defined by the midpoint of our 2 events. So in this case, if you think of just like 1 plus 2 divided by 2, that'll give us 1.5, or the midpoint there. And in addition to that, we will use our underlying data and the value of seconds elapsed to plot the y-coordinate of our control point. Once we've plotted those things, we can basically insert those, just like you saw Adam do in one of his equations, into the Bezier curve equation. And what that looks like is, I'll show you in a few slides here. Once we've done that, you'll then drag that onto your views, and you'll have curves here. But why do we need curves? That's a question I get often when I'm talking to people about things like the jump plot. Why do we need the curves? This goes back to the original use case of the graph that I mentioned in the beginning of the session. And that is the fact that if you are jumping between multiple events here, like if you don't have every single event get hit, the use of curves will allow you to follow that series and keep the structure of that series a little bit better than it would if you use something like a dot plot. So here's an example of that in action. So this is a jump plot that's trying to show information about a development cycle. From left to right, you have events along a development cycle, and we can just make those up for now. So the first one could be, starting design or something like that. Third one might be doing development. Let's say the fifth one in there is maybe starting testing or something like that. But this gives you a view of, if we wanted to take a look at Marlins, how they're progressing across each of these steps along the way. You could look at this data in the same way with a dot plot, if I were to switch this. And this is the same exact information. It's the same points. I'm literally using the control points from the Bezier curve here to show you this graphic. And that's why the axis is off, by the way. I can explain that. And in here, we have the values. And you can see this kind of grouping of these dots here. And so really quickly, I'd like to explain why the axis is off. And that's because in order to pull the Bezier curve to the correct value in a jump plot, or whatever you're doing in that matter, you're going to want to actually duplicate the control point value. So the reason why you see 70 on the left and 32 on the dot that I'm hovering over is because I'm trying to represent the value 32 in the curve, but the actual control point that's pulling the curve up that you don't see in the visualization is actually at 70. So that's why that looks off. Going back to the jump plot again, you can decide for yourself whether or not that's a good way to visualize that. All right, so let's get into building it. And so what we're going to do to build it is I'm going to start by dragging path onto my details shelf. And if you remember back to the data example I showed you earlier, path was the line ID, basically, that we're going to be using to make our data visualization here. I'm going to take our bin value, and I'm going to drag that onto the row shelf. And just to show you how that goes down, that's from 0 to 100, and it's sized by 1. Here's where I can turn on and off densification, just like I did in the bar chart. And what I'm going to do now is change this to a line and put that onto the path of the line. So it doesn't look like much right now. We have a blue circle in the middle of the viz. There actually is over 1,100 marks drawn. They're just drawn right on top of each other on that blue circle. And what we're going to do now is we're going to use our Bezier curve equation, which I'll show you here. And in this equation, you can see this is my starting point, this is my control point, and this is my end point. And the rest of that is the math just like Adam had to make this all work. I'm going to drag the x value onto columns. And this is my favorite part. I'm going to drag the y value onto rows. And then you get this result. So from here, what you would do is basically just style it up the way we were showing you before. So I'm going to put gender on color. I'm going to size down the lines, however much you want. And then if you wanted to, you could also do like a dual axis to draw the nodes that you saw in the first example that I showed you. Couple of variations that I wanted to walk through today. The first one here is called, we call it the jump line, and it's basically a spark line for jump plot. Hopefully it will render here at some point. It's normally not that slow. Okay, so what you're looking at again is this is actually the same home run data from the Hit Tracker Online from ESPN site, and this is the 2016 season, the league leading home run hitters. And what the idea behind jump line is just the same as spark line, right? So what we're trying to do is we're trying to graph this information, visualize this information in line with this other rich data source that we have. And we've sorted our hitters in terms of the number of home runs they've hit. And we get a couple things out of the jump line. First and foremost, just by definition, it basically acts like a bar chart. As you can see, the number of home runs will drive how long the line is. So that's an added benefit that we get. Then in addition to that, you can use the hops, which are represented by the curves here, in order to find consistency or inconsistency in how often people are hitting home runs throughout the year. So for example, we have Edward Encarnacion here, and he has 11 home runs at the maximum that he hit, or I'm sorry, he has 11 days between a home run in the year, and that's represented by the orange hop here. And I have that color-coded because I'm using an independent axis for each hitter, so I'm trying to give you an identification of what the scale of those hops are. And you can see when looking at his that he's actually pretty consistently in terms of the number of days between his home runs throughout the year. We look at somebody like Brian Dozier, and he has a lot more time happening in the beginning of the season, and then he kind of picks up his pace towards the end. We can take this now, we can flip it on its head, and we can look at pitchers. So in the version we were just looking at, tall hops were bad. Those were situations where hitters were taking a long time to hit their next home run. And now we're looking at a situation where tall hops would be good. And this is a situation where pitchers have had multiple days elapsed before they allowed their next home run. And it's an interesting way to kind of flip the table on its head and look at it from a different lens. And as we scroll down here, we can see, situations like David Price, where he had, a number of home runs hit off of him pretty consistently, and then he had this one situation where he went 28 days without having a home run hit. And then lastly, I just wanted to point out that you could show the same charts in something like a trellis panel as well. Whenever you're using a trellis panel, you want to follow the best practices that go along with doing that. And what that really means here is we're doing this in order to look at each of these items in more granular detail. So this is the same marathon data we looked at in the beginning of this session. You can see here that I've split it out into 6 panels, and that's done by year. So I think the top left one's 2015, 2014, and so on. You want to order those in a way that makes sense if you're using a panel. And again, here, the idea would be to really focus in on each year on its own. If you're focusing on trying to compare those years, it may make more sense to not utilize a panel in those situations. Ultimately, the decision's up to you. All right, let's talk about Hiveplot. How many people have seen a Hiveplot? Awesome. So you probably may know already if you've followed any of the stuff I've published publicly that I'm a big fan of them. I'll start by just explaining how you go about reading it. So on the top, we have the axis for Tableau and Tableau vendors. So this is a Hiveplot of tweets about Tableau conference from 2015. It's filtered down quite a bit to simplify it in the example here today, but that is ultimately what we're looking at. So the nodes on the top center axis are Tableau, Interworks, other companies like that, Databricks. And in addition to that, we have on the right there, the blue nodes. Those are everybody else who may not necessarily be affiliated with Tableau or the Tableau community. And then on the left in the orange circles, we have Tableau Zen Masters, social ambassadors, other people like that. And the curves here are drawn to show a relationship between the individuals. So these are people that have tweeted and mentioned somebody or retweeted somebody else's tweet that had somebody mentioned, so on and so forth. So why and when you would use this? You would use Hiveplot in a situation where you're looking to graph a network. You would want to use it instead of other network graphs, so when you would want to use it. In situations where you're looking to do comparisons or if you have degree or dimension-based networks that you think can be laid out in this fashion and that adds value to what you're trying to convey about the network in your visualization. Stephen Few has some information on his blog around network graphing, and his commentary there is mainly that network graphs can be extremely dense and hard to consume. I think that's pretty hard to argue. I think when you're plotting thousands of points on a screen, it's going to be dense and hard to consume. He lumps Hiveplots into that category, and as a result of that, we went ahead and put on here that they're probably not his favorite thing. With respect to Hiveplot, we have a post on Databricks that'll go through all the granular details of what I'm about to walk through rather quickly right now. So if you do want to go through and deconstruct this, you can do that from the Databricks site. And also, Martin Zawinski, who's the one who came up with the Hiveplot, has a site, hiveplot.com. I think it's just stunning if you look at some of the things on here, but he also goes into great detail of why you would want to use a Hiveplot versus your traditional network algorithm-based layout. All right, so in the jump plot, we leverage Bezier curves. In the Hiveplot, we're leveraging Bezier curves to connect those relationships. The reason why I chose these two examples, or one of the reasons why I chose these two examples, was I wanted to show how you can make very different outputs using a like technique. So I know there's a lot of different examples of that out there, but this is something that I thought would be interesting. The other piece of information that happens here is instead of in the jump plot where we're just plotting everything on the x-axis, we're actually plotting things on multiple axes across the plane here. And the way that was easiest for me to think about doing that was by leveraging polar coordinates. And so in order to leverage polar coordinates, we need to think about our space that we're going to be graphing points in a little bit differently. We're used to thinking in Cartesian, which is x and y. But with polar coordinates, we're going to think of things in terms of distance from origin. So this would be our origin point at x equals 0, y equals 0. And then we're going to also think of things in terms of degrees from a point of reference. So as I move this radius in and out, you'll see my chart there constrict and expand. And then in addition to that, as I move the degrees, you'll see those shorten and grow. And what I'm ultimately showing you here in this graph is a radial bar chart at the end of the day. So that can be your bonus chart. That's our bonus fifth chart that they can have. And lastly, I just want to point out again, the Wikipedia page is a great reference for polar coordinates as well. So if we look at the how-to for HivePlot, we're going to be doing this very similar to how we did it for the jump plot. So we're going to start by building our points that we need to draw our Bezier curves. So the first thing we're going to do is plot our start and end points, and that's where the nodes need to sit on the axis. So what I've done here is I've actually have some calculations in there to say, okay, Tableau's a vendor, so put it on the top axis, which means make it at the degrees of reference 0. They're the most popular tweeter in that axis, and so as a result of that, we're going to put them on the top or in the middle or wherever you want to do. So you can move around, you can group, you can do things like that with the HivePlot. I actually have also split the axes here, which I didn't talk about earlier, and that's just meant to show the interconnectivity within that single group of people as well. Once we've done that, we're going to go ahead and draw our control points. And the control points, again, are based ultimately on a midpoint formula. It does get a little bit more complicated when you're dealing with 3 axes instead of 1, but it's the same concept that I mentioned earlier with respect to identifying the middle point between those 2 things and then plotting that. Once we have those things, we can again just plug them into the same Bezier curve equation that we were using, and from there it's just a matter of formatting and how you want it to look. So I have an abbreviated build here for this one. I'll definitely admit that. In my calculation, just to show you, this is the exact same curvy calculation that I had before. Start point, control point, end point. And I'm going to drag that onto columns. And I'm going to drag the Y value onto rows. And then hopefully our graph will appear. There we go. I do have to admit, you can see there's quite a bit of information over here on the marked card in terms of detail and path and all sorts of stuff. If I mouse over this, you can see there's quite a few table calculations in there that I'm using. So the good news for you all, though, is that I already did all this, so you can just go download the workbook and copy and paste it. You don't have to worry about any of it. So I felt like I was obligated to admit that when I'm dragging one pill. Before I wrap up, I want to mention a fun little project that I'm doing with Keith Helfrich. And we've actually been harvesting tweets throughout conference as the conference has been going on. We decided it would be a fun idea to go ahead and create a hashtag of our own and see if we can grow a network about people talking about our network graphs. And so that's the hashtag Data16Net Twitter hashtag that you see up there. And if you all like what that screen is showing you there and want to talk about it, or if you don't like it and want to complain to us about it, you can do that too. You'll still show up on our graphs at the end of the day. This is the view as of this morning. So I think we finished harvesting around 10 o'clock this morning. So that includes some topics like devs on stage and other things that have happened pretty recently. And with that, I'm going to ask Adam to come back up and join me, and we can go ahead and do some Q&A, and then I think after that, we'll wrap up the session.
Good job, man.
For everybody who's booking out of the room, please remember to fill out your survey, and thank you for coming. Yeah. Thank you all for coming. We really appreciate it.
Hi, guys. That was amazing. Thank you. How often do you get asked to create charts that you simply don't want to create in Tableau, and what sort of advice do you give?
Do you want to take that first?
Yeah.
Because you probably get asked more than I do.
Yeah, a lot. So I think one of the things we have is, clients have data and then they have an end goal, a visualization as an end goal, which is usually not the right way to go about it. You usually have data and then a question, and then you have an answer as your end goal. So I get it a lot where they say, hey, I want this to be a bad chart type, like a gauge. And what we try to do is we try to guide them to the right chart type. And so like a HivePlot, I actually showed one of Chris's HivePlots to one of my clients. We were doing something slightly different. And we were like, this is a cool way of visualizing it. It's very, it's perfect for our need. They were overwhelmed by it. So I think as long as you explain to them, the purpose should be what's your data, what's your question, and what is the answer you're trying to arrive at, and then sequence the chart from that way rather than saying, this is the chart I want to get at. How do I make my data fit that story?
Yeah, and the only thing I would add to that is in situations where you're asked to make a chart that you know there's a better way to do it potentially.
Yeah.
What I would do is actually build both and just try to prove out the fact that if you look at both of these things together, the better way to do it is probably going to come through. You're still going to run into situations where people say, I don't care, I want that instead.
Yeah, it happens a lot.
It depends on if they're a boss or a customer at the end of the
Yeah.
day, right? Anybody else? The mic.
I think your Beetle Viz is awesome. And I was wondering, the lines that you drew, they were the bar chart to show where they were on the Billboard charts for each artist. Were those mathematically calculated like you shown here, or was those manually, or was there a tool used?
So yeah, just so everyone knows, I'll bring it up. So this is a Beatles viz I made actually the day my daughter was born, because I was in the hospital and we were just waiting. So I made this. I was just waiting. So I hadn't been working, so I was bored, and I wasn't sleeping, so I might as well do some vizzing. But yeah, the Beatles viz, the lines. So it's a little small here, but the lines are every hit that the Beatles had, and then the lines map down at the bottom here as to who wrote it, whether it was John and Paul together, John individually, Paul. So this actually I stole just aggressively from Jeff. So the middle chart, it's really just three charts.
I stole that from Jeff.
We all steal from Jeff.
Yeah.
If you're going to steal from someone, steal from the best.
The one on the top right steals from Jeff too. Yeah.
We all stole all of our stuff from Jeff.
Yeah. That's the theme of our talk today.
Yeah. That's the end. Jeff Schaefer, by the way, if you don't know what we're talking. But it's really just three charts. It's a bar chart here, the middle chart, the height represents how successful the song was, and then a Sankey chart at the bottom. And so the Sankey is from a formula or from an approach that Jeff created. It's been since modified from there. Roddy's done some cool Sankey stuff. But yeah, that is a Sankey chart. And for more details on Sankey, I would read Jeff's blog or steal Roddy's stuff. Yeah, we all just steal circularly.
Borrow and attribute to, right?
Yeah.
One more.
I was wondering if you guys could talk about your design process when you're thinking about a question and you need to come up with an answer with data. Like, how do you decide what chart you're going to work on? And then once you have an idea in your mind, how do you design that and actually implement it?
Can I ask one additional question? For business or for fun?
For business.
Okay. I can start on that one, I guess. So when I'm designing something for work, the ultimate goal for me is the first thing I try to figure out is who's it for? Am I designing this for my team specifically, who's pretty acumen at reading charts and stuff like that, or is it somebody I don't really know? Is it somebody higher up in the organization? Are they going to be looking at it on a different device, something like that? All that will play into what type of chart I actually end up building. With business, you want to be very accurate, you want to be very clear, and you want it to be concise and easy to read. A lot of times that leads you down the roads of things like bar charts and bullet charts, like you mentioned earlier, as the way you would want to go. Depending on the use case, I have used things like JumpPlot at work before. I used to be in the audit area, and within that area, we would look at things like the purchasing cycle for our company or something like that. And you could use tools like the JumpPlot, but that's for like an analyst level person. I wouldn't really use that to report up to the CAE what I found or anything like that. So that's the process I go through.
Yeah. So in a business setting, Deloitte uses what we call a persona-driven approach, which means we spend a good deal of time identifying who the personas are, what are the key questions they have, what is their level of comfort with data, statistics. So if we're going to make a complex chart that says things like confidence intervals, which might be complex to some or simple to others, you got to make sure that they understand what a confidence interval is. If we make a box plot or a bullet chart for a client and they ultimately don't understand what most of those marks and reference points means, then it's essentially meaningless. So Deloitte is very key on persona-driven, know who your audience is, know their level of comfort with the data. And then I think most of us use Stephen Few for our guidelines as to what is the appropriate chart type given their level of sophistication, given what you're trying to communicate. We've had a little fun with Stephen Few, but we've all read all of his books. Both of us have read all of his books. We're huge fans of his work. He's good at guiding you down of, you want to do this, these are the reasons you should use a bar chart, a line chart.
Yeah, I agree with that. One more over there.
So I had a question about your network charts. So many of times when you build out the network charts, do you ever come to a point where everything just grinds to a halt? You see the computing data, the whiz, computing the whiz, computing your data points, going
Yeah.
on and on and on. And
Absolutely, yes. It goes back to how many things are you trying to put on a page, right? There's some tricks that I've come across recently actually to lessen the amount of marks that you're drawing, because if you remember back to the densification that I showed, I'm actually adding 99 marks into the page for every single line I'm going to draw, right? So the scalability of that could become a problem depending on how many marks you're trying to draw. The one that Keith and I are doing right now, I forget exactly how many it has. It definitely has at least over 1,000 relationships on it, and it renders in a couple seconds. So it's not too bad. But that one I've applied some additional tricks to in order to speed it up. The answer to your question is yes, that definitely happens. In those cases, I try to limit how much data I'm showing or potentially use something else to graph it.
my question was because most cases I have less underlying calculations than you have. And yet I run into more issues than you do.
Oh, yeah?
Probably 15, 20 seconds, 25 seconds.
Okay, yeah. So it could go back to how your data is structured, where you're pulling it from, whether you're using extract. There's a lot of factors that could cause delays in rendering in a workbook. I'd be happy to talk to you more about it afterwards if you want.
Thank you.
Yeah.
So I'm curious, just looking at this Hive plot, are you making design decisions on where you're choosing to put each node? So
Yes.
I'm thinking that you would interpret the same thing quite differently if you put two frequent connection nodes close to the axis as opposed to far away.
Yes, I mean, that does play into the design aspect of the Hive plot. That's actually a strength of it. If you think of it that way, you can help structure the network diagram in such a way that those types of things stand out. That's one of the reasons that Martin Zawinski talks about it versus a standard algorithm-based network layout where you might run the same network through twice and get a different result. You can manipulate where you want those things to go. Obviously, you want to do that with the intention of making the graph more clear. I've made decisions on this for the reasons that I made them. There's things like the split axis. I didn't have to do a split axis, but if you want to be able to see any of the connections between people who may not be related to Tableau but tweeting about our network project, you have to split that axis out to actually see that information.
Any other questions?
There's one over on the side over there.
I was just wondering if it would be possible to do like a drillable network. So you would drill on one point there, and you would see another network for...
Yes, you can do that. I have an example. I actually built my family tree in Tableau, and it's a drillable family tree. So for example, if you click on me and you say, look at all your descendants, you'll see my two children. And that's up on the Datablick blog. So if you want an example of how to do that, that's there. And this example that we're showing you here, actually, as you can't click on it because it's a picture, but if we were to click through the different hashtags, it would show you different network graphs for each of those. So there's a couple different ways to do that. I go through one example on my blog post about my family tree. It does involve more pre-processing, I would say, because you're basically going to pre-build some of that.
Yep.
I don't know. Have you ever done like dynamic drillable all done in Tableau? I've always pre-processed.
No, because usually to create the network chart, and I think Keith did that in this one.
Yeah, he did the network chart.
Yeah, when I do network charts, I usually do it in R.
Yeah, and he did
then
that too.
it pre-positions the X and Y coordinates
Yep.
based off the data you feed into R. You could write some R integration scripts to pull it back that as you're the density of your network changes or expands or shrinkens, you could alter the layout.
Right.
But our integration sometimes is
It's
tricky.
slow, right? I think for the most part, if I have done that, I've pre-processed it.
Yeah.
Yeah.
Same here. Nadia Bremer has an awesome network. I'm a big fan of Nadia Bremer.
Oh my God, she's,
Yeah. So she has a website, Visual Cinnamon.
yeah.
We steal from her. I steal from her. But she has a network chart up there now. It's called Royal Constellations. It's the most
yeah, that
beautiful
one's-
network
that
chart.
one's cool. Yeah.
No offense.
There's no offense taken there. I saw that
It's
too, and I
gorgeous.
was like, man, this is amazing. Yeah,
Very
I would definitely check her site out.
Steal from her.
Chance. Yeah.
Steal from Jeff. Any other questions?
Anything else?
Cool. All right, so we're just going to close with please fill out the survey.
Correct answer is 5.
Yeah, 5. Again, all of our material will be available on our respective sites. We're going to post it so you can download and reverse engineer it. And for more information, you can follow us on the Twitters.
Thank you very much for coming. We appreciate it.